Hello everyone, I'm Xiao Gang. Okay, let's open this C++ version, and then launch it. Actually, you can see its presentation is the same as Blueprint, but in terms of writing style, difficulty, and hierarchy, the C++ approach is much more complex than Blueprint. Let's first take a look at the Blueprint level, see which parts are the same, and then we'll explain what C++ does. Because we know that a lot of work is actually converted between Blueprint and C++. And we can see predict setting in this input section. We are still using the enhanced input system. These two classes, this part is fine. Then here in our content directory, this is the observation prototype, should be fine. And these are some model assets, no problem. And this is the character model asset. We'll just copy one over later. Then the difference here is, so let's start from this. Ports, the inputs are still the same. You can see the inputs here are all the same. These atomic products, right? Then we mainly look at this blueprints. So how is this blueprints different? First, look at this game mode. This game mode actually, it doesn't write anything, but it is actually a bit different. It is roughly the same. Then we look at this player controller. It is different. In our previous player controller, it wrote this thing for registering the input configurations mapping contents. And here, it only marks this asset. Its registration is actually done within this player controller. We'll just look at it in the player controller later. Right, and this is the player controller. So then, let's take a closer look. Then we move this up to keep it from jumping around. Okay, here, as for this character, because I noticed its applied graph, its blueprint logic graphs are all empty because most of its logic is written in the character. In here, we set it to she only modifies. So here it specifies the corresponding 3 input actions to facilitate binding at the C++ level. Okay. And these are some navigation related things. We ignored them. These are some blueprint settings and parameters. Then we compare. This and this are fine. This essentially just moves the forward, backward, left, right, mouse movement, and jump logic to C++. Now for something a bit more complex. It's this pickup and this first-person projectile. Let's look at the projectile first. The projectile is quite simple. The projectile is simple. It actually just has some elements. And then there are some size settings, some configurations. The main thing is you can look at the parameters of this projectile. Here, some launch speeds are set. Nothing much to say about these, because this projectile is only something generated afterward. To do that kind of thing, and its parent class is this projectile, the more complex one is pickup. Then look at this pickup. It has these 2 components, but these 2 components are both components. This component is this one. This component is the weapon component. This is the pickup component, and you can see the pickup component inherits from software component. So there will be a collision multicast delegate, essentially, at this point. If a collision occurs, then it will activate the delegate. This delegate is deactivated in Blueprint. When it is activated, it will call this weapon component. In the weapon component, it deactivates the attach weapon, such an event. So regarding this attach weapon, it actually here will attach this thing to our character. You can see this delegate. So this part is actually a bit convoluted. Then when attaching this delegate, it also needs to map this input, register a weapon input mapping. So this part is quite convoluted. You should keep this in mind. Then this is the projectile. As for the projectile, this is its defined C++ parent class, projectile component, collision component, and here there is when it hits, it will go to destroy. And this is the life cycle, right? Now let's take a look at C++. When we look at a project, we first look at the uproject file. You can see some version information, and obviously it has only one module, which is the game module. So this is the FPC module, and you don't need to worry about this plugin. It's some model plugins developed by the engine's own editor. Don't worry about it. Then here, let's continue looking at target.cs and editor.cs. And here obviously it can be packaged into a game mode. Right? And this one can use this editor. That is to say, there's nothing particularly special about these 2 target.cs files. Next, we have build.cs. Build.cs is the same as our normal build.cs, but here there is an enhanced input system. So this proves that it needs to use some registration functions of the enhanced input system. And this module file, nothing much to say about it because it doesn't have much written in it. it is the game group module. Generally, we don't write anything, so it just uses it directly. It uses the default generated module. Then the default module files are fine. If you need to, you can implement it. If not needed, just let it all use the defaults. Just do nothing. Let me get the game mode. You can see that in the game mode, it actually does nothing. It mainly just changed the default upon class. We can specify it in Blueprint. We can do it at the C++ level by searching in this way. It is also possible then in the player controller at this location. This location specifies this input mapping for up, down, left, and right. Then in gameplay, it uses this method. To get the local player subsystem, it must be obtained in this way. After obtaining it, because you just don't need to register it here. There is a fixed way of writing. Register the forward, backward, left, and right inputs here. Then we look at this character here. This character inherits from a character. Then we added several components. These places all have forward declarations to avoid including too many things. The actual includes are all behind this. In these places, we need to use components. This is the mesh component, and this place is our camera. This is our hand. This is an implementation action for jumping and moving. And these two things, this thing is actually an action for when we look. Then this thing, how are these three things bound? They are bound through this method. This comes from the pump interface. So here, it will pass in an input component. Then this input component, it can be converted downcast to our enhanced input conduit. Because in project settings, we made this specification, right? Once the specification is done, we can then, in input X, according to this enumeration, according to this trigger event, bind it using this enumeration. Then we just need to bind the corresponding method. This part is directly bound to the fallback method inside the parent class, right? This part is bound. Then the movement is bound to its own. As for the movement, it's actually very simple. Just get this value. Because our movement's input action is a fake 2D value, then we extract the X and Y, then calculate the forward direction of the actor and its right direction. Just add it in like this. As for this look, it actually gets our mouse's Y values and then directly adds them to our controller's rotation and then controls it like this. And because in the construct we enabled this pawn controller rotation, so the mouse rotation will drive this pawn character to move. And basically that's about it here. Then at the very end, some get methods. There's not much to say about getSet. It's just convenient for when you need to get this pointer, because this variable is actually private. It's private here. Then if we look further down, let's take a look at the constructor. In the constructor here, it uses a method called initCapsule to modify the size of its capsule component. And here, because they are all pointers, these are all raw pointer. That is, it doesn't use a top. We won't worry about that. Using raw pointers is the same. And here the pointer hasn't actually used this object yet. So to have this object, we will use CreateDefaultSubobject, this method, to create such an object. Then after creation, we attach it to its parent object. This establishes a word hierarchy relationship. Then we set the relative position. Then here, this places the camera. With the camera ready, we will next create this hand. This hand, of course, only needs to be seen by ourselves. So we set O1. This is a common practice when shooting. Then at this point, we attach it under the camera. And at the same time, we turn off the shadows because only we can see it. We don't need to cast shadows. Then set the relative position. So the constructor is done. Then next is begin play. This is binding input. This is the specific input mapping method. Okay, so that's it for this character. Then the main point. There's probably not much to say about this projector. It just specifies a collision component here. And then this projection component. Then in the collision part, we mainly create the corresponding collision component. Then bind this hit method. When it is bound, we take the object it collides with. According to this function signature, we have used this binding a lot. Used it too much. Then we add a physical impulse to it. Finally, destroy itself. Then here we give it a default lifespan. Then here is the projectile component. For this projectile component, we also need to create a projectile component, then attach it. Then here, set the parameters of the projectile component. Perform a configuration, then it is done. Okay, so let's focus on this pickup component. It inherits from the Sophia component. This indicates it is a collision box. So this collision box is located here. It only modifies the corresponding size, right? Because the Sophia component has this size. This size, then in begin play, a binding is made. That is, when a collision occurs, this event is triggered. this event will, that is, it will trigger once after a collision. It just cancels it. It prevents it from being generated. Then here we get the colliding actor. Then cast it. If the cast succeeds, then we make it do something. Make it trigger the dynamic multi-wave delegate. This is bound in Blueprint. Blueprint bound, you can see here. This delegate is implemented in Blueprint. Then after the Blueprint is bound, it will call the WeaponComponent on this class. And this WeaponComponent has many parameters. These are all resource classes. Which class was generated? The sound emitted, the montage used, the muzzle offset, then the registered input mapping, and the specific input mapping action. Then there is its constructor. Then these are several methods. The fire method, AttachWeapon method, some methods for when the game is about to end. Then we can take a look at what is written inside. Obviously, in the constructor, it only needs to give a default value to this parameter. So let's look at AttachWeapon first. AttachWeapon, first you need to get the character, and it does not have this weapon. If it already has a weapon, then you don't need to add it again. This way, if you add it twice, it will have 2 weapons. Then 2 weapons firing will produce 2 balls, which is wrong. If it does not have one, we go and get the corresponding component. Get the socket from within the component. Just add it directly. And here, add an instance component. Add such a component to this actor. Then here, we have a player control here. Just set up the corresponding input mappings. Okay, after the input mappings are set up here, actually, when it ends, it seems we forgot to tell you. It seems we missed this one. That is, during unplay, it needs to also remove this input mapping because you no longer need to respond to this input mapping. Missed this one, but don't worry, we will definitely include it when we write it later. Actually, it doesn't have this unplay written here. This part, it's missing. There should be an underplay in the play control. Yes. So why is there no underplay here? It's because the player's play control actually exists throughout this level. Yes, and the reason for underplay here is we explain that you switched weapons. In other words, you can understand it as meaning that here it might be a weapon switch. So on one side, an underplay was written. Okay, good. That should be the meaning. Normally, that is indeed the case. When you no longer need this, you need to unregister it. Just reverse and cancel it. This is a concept of dynamically requesting resources. Then when firing, it's relatively simple. You just do some muzzle position calculations and then use spawn actor to do the related generation. And on this side, if the sound resource class is not empty, we play the sound. If the animation is not empty, we get the animation blueprint by retrieving it layer by layer. After retrieving it, we can play it. Okay, so basically for the entire C++ part, we have analyzed it for you up to this point. Yoho, I think quite complex. Although you only see these few classes, how each class is thought out and how it is designed, we still need to guide you through writing them. So let's stop here for this lesson.